Hi, I'm Jason Delacruz, K4FLY. I don't live in an area with an abundance of digital repeaters, so I often count on one of these multi-mode hotspots to tap into the digital networks. I know many of us have several of these and maybe one dedicated for use in our vehicles, which is what this post is about. In addition, a few months ago, Yaesu released their new PDN mode, and since then, I find myself also carrying around one of these small form factor PCs in case I want to run Wires X on the go. So I started thinking of a way to get these into a more permanent fixture in my vehicle. And I know that we have to be cautious in the way that we shut these down in order to avoid damaging the file system. So I wanted to come up with some way to automate a graceful shutdown sequence when I turn my car off. Then I thought if I managed to achieve that goal with enough of a delay, I could effectively create a sort of Wires X node on the go, which would allow me to, say, park my car somewhere and continue using the Wires X node via my handheld radio, and have the system automatically shut off, say, in an hour so I wouldn't drain my car battery. So here's what I came up with as a solution. So let's have a look at what this is and how it works. Okay, so the project consists of two timer relays and a Raspberry Pi. Raising the signal line to 12 volts triggers the relays immediately, closing the circuit to the power bus and thus powering up all of your devices. The shutdown sequence is a little more interesting. Lowering the signal line triggers both timers to initiate countdown. The shorter of the two timers belongs to the GPIO relay. It expires first, causing the relay to trigger a GPIO pin on the Raspberry Pi. A small Python script running on the Raspberry Pi detects this change and broadcasts a packet on the network telling all other computers to initiate safe shutdown. The Raspberry Pi then itself shuts down. Finally, the power relay's timer expires, cutting power to the power bus. Once the Raspberry Pi and PC stick completely shut down, their power consumption is minimal, so why bother cutting power to the power bus? Well, both the Raspberry Pi and PC sticks support automatic boot up on power, so having a power relay enables us to have a mobile setup that automatically boots up your devices when you turn your ignition on, and safely shuts down your devices when you turn your ignition off. On the power and signal side, both timer relays are bridged. The signal line runs to one of the fuses that is only powered on when you turn your ignition on. On the relay side, the power bus relay is wired up such that it can close the circuit on the power bus, and the GPIO timer relay is wired up to one of the GPIO pins on your Raspberry Pi. The timer relays and Raspberry Pi can be mounted on plexiglass or neatly stacked using standoffs. For this demo, we will unstack them so we can get a better picture of what's actually happening. The timer relays are permanently powered up. Once configured, we can turn off their displays for minimal power consumption. To power up our devices, we need to raise the signal line to 12 volts. Normally, we would run a wire to our fuse box where we would tap into an existing fuse slot using a fuse tap, which allows us to keep the existing circuit's fuse as well as add a new fuse for our external device. You can buy these from Amazon or your local automotive shop. For this demo, we will simply connect the signal line to our 12-volt power supply. Once connected, we see our router, PC stick, and Raspberry Pi immediately power up. Okay, so our system is now fully booted. I've embedded our Windows PC view on the left-hand side, and we can see our software is now running. To initiate shutdown, we need to lower our signal line. As soon as we do so, we see that our timers initiate countdown. The timer on the left is shorter than the one on the right, and it's the one that signals the Raspberry Pi to tell the rest of the devices to initiate shutdown. The timer on the right is the one that eventually cuts power to the power bus. If we change our minds and decide to turn the ignition back on, we simply reset the timers. And we can do this any number of times without having any impact to the devices that are up and running on our system. We will go ahead and wait for the timeout to actually complete in order to see what happens during shutdown. Okay, so our GPIO timer relay will trigger in about 9 seconds, telling our Raspberry Pi to send out that signal which tells the rest of our devices to initiate shutdown. It has now timed out, and the signal immediately reaches the PC, causing it to shut down. We can also see that our Raspberry Pi proceeds to shut down itself. Our light goes off now. Finally, the power relay timer will trigger in about 5 seconds, cutting power to the power bus. Our system is now fully shut down. Although this demo focused on my specific problem space, the same solution can be used for automating a proper shutdown of any computing device on board your vehicle. Just remember not to exceed the maximum load supported by the timer relays. I hope you found this useful. Thanks for watching.